Hello, you're watching the Green Network Summit, part of our year-round DSP Leaders coverage. I'm Guy Daniels, and today's discussion looks at how to leverage cloud native for network sustainability and efficiency. What tools are available to telcos and how can they utilize the work being done by the global developer community? Can telcos use this opportunity to reset their network development and operations efforts? And can they really build a more energy efficient software-based business? Well, to answer these questions and more, I am joined on the program today by Komal Aggarwal, who is Energy Digital Transformation Manager at Vodafone, Maria Lema, who is co-founder of Weaver Labs, Joan Triay, who is Manager and Network Architect at Docomo Labs and also an ETSI NFV rapporteur, and Beth Cohen, SDN Network Product Strategy at Verizon Business Group. Hello everyone, it's really good to see you all. Thanks so much for taking part in our discussion today. So let's start by asking what is currently happening within the developer and open source communities that could benefit telcos in terms of network sustainability and energy efficiency. And perhaps I could start by asking Komal, you're the telco, one of our two telcos on the panel today. What's your experience been and what do you see?
Thank you, Guy. I think there's a lot happening in the community at the moment. And before we answer to what's happening, I think it's important to identify why that is happening, to just lay the foundation of the response. I think telcos are one of the largest electricity consumers. And as we see the demand for network grows, which it will grow, the network will have to continuously evolve to respond to that demand. And that inherently means that the demand for electricity will go. So what's happening in the community out there right now is the focus on the tools to make sure that we have the right tools at our disposal to make sure that we respond to this ever rising demand in a more sustainable fashion. So I think with that, we already see there's a lot of advancement going on, Kubernetes, containerization to make sure that we are optimally using cloud for optimal deployment of network. That's obviously out there. But I think there's a lot of happening on the hardware side of things as well, where processing technology is being focused in order to deliver more energy efficiency so that telcos can go towards the 0-bit, 0-watt target. Then I think there's a lot happening also on the Open RAN side, where especially on the software integration, where in today's world we are delivering a significant amount of energy savings using software features. So the objective is that once Open RAN is more widely prevalent, we do have tools like software features to deliver similar kind of savings. And I think at the end, last but not the least, I would also add that there's a lot happening on the AI side of things too. I think with all the tools that are enabled on cloud, there's a lot of downstream analytics that's happening using AI. And from simple things like having more accurate energy forecast to more accurate traffic forecast, which can enhance the way we procure and factor in renewables into our sourcing profile, to more complex things like more digital twinning of the network or more flexibility, electricity grid integration. So I think there's a lot happening out there at the moment.
Great. Well, that's a great opening perspective you've given us there. Thanks very much for that. And I know you mentioned hardware, and I'm sure we'll come back to that. It's not all about software. The two are very much interdependent. Beth, you've been working closely with developer communities. What are you saying, or what do you think could help telcos with this mission?
So I want to, build on what Komal said. There's a number of initiatives within the open source community. Obviously, ORAN is focused on the radio component, and within LFN, Linux Network Linux Foundation networking, there's a number of projects that are focused on designing reference models and reference architectures to support energy, reduced energy workloads. And that includes the Anakit project, which is a reference architecture to support cloud native CNFs and VNFs as well, because many of the many of the telco workloads are still virtual machines rather than containers. And I know we're going to be discussing that in more detail later. So there's a lot going on there. Komal mentioned AI. AI is sort of a good news, bad news topic, because the good news is, yes, it can deliver better energy efficiency, but the bad news is that it takes a lot of energy to do that. So, I think there's a balancing act there. But there's definitely work happening in the open source community. And of course, hardware plays a big part of it as well. So, the initiatives are really just starting now. The hardware initiatives are much further along than the software initiatives, but we're all working toward the same goal, which is to reduce our carbon footprint and increase the efficiency of delivering new services.
Thanks very much, Beth. Yes, as you say, we are all working towards this same goal, and hopefully we'll develop some of these themes later in the program. I mentioned, communities and developer communities and open source communities, but Joan, there's also the standardization and standards communities. These two operate together. Is there any extra perspectives you could bring us here?
Yes, definitely. And I fully acknowledge all the good things that are being developed in the open source community. They are delivering quite very good enablers that allow the operators to monitor the power consumption, to even perform power management on hardware resources and even containerized workloads, virtualized workloads. But I think that we also need to add a perspective from the full stack. So we cannot just only focus on what is the infrastructure, because in the end, we are also deploying networks. So here, I would like to highlight that it's important to also consider all the efforts that, from a standardization point of view, different organizations are doing, like, for example, ETSI, NFV, DMTF, Redfish, 3GPP, on trying to normalize KPIs and measurements that are related to power efficiency, energy efficiency, and power consumption, which allow the operator to actually understand how power is being consumed, and also provide the necessary tools to make a comparative evaluation on where power is being consumed, and also compare the different deployments of networks, and to try to evaluate where is the actual improvement and where we can add it. And therefore, I would say that normalization and standardization done, it is still critical. And of course, jointly working together with the open source communities, that is a win-win.
Great. Good points, Joan. Thanks so much for making those. And it leads us quite nicely into our next question. Maria, let me address this one to you first, because Joan mentioned KPIs there. So how can telcos improve their green targets by adopting cloud native? And are there any recommended cloud native tools or applications that may help them on their way?
Yeah, I think this is a super interesting question, specifically because, we always address the telcos as the service provider, but service provider by software from vendors. And this is where all starts, right? We can create software, a very inefficient software, and put it in containers and then hand it over to the telco, to the service provider, and think, there you go, right? Handle it. And we actually need to start by creating more efficient software. So I believe tools that have been used by the IT industry, enterprise tools such as messaging systems, or microservice architectures, agent-based architectures, allow us to create a lot more efficient software that would in turn use a lot less CPU and obviously consume less power and make the most out of the servers. One of the things that I always it always strikes me is that it doesn't matter if I am building a private network for a factory or if I am building a network for, you know, an MNO. I'm going to buy the same code base. So I think the tools from an software architecture perspective that allow us to be more service-based rather than just blocks of code are going to allow the software to be a lot more efficient. So for instance, a lot of the work that we do is to transform bulks of software into more agent-based microservice architectures using messaging systems, for example, right? So messaging systems, there are a ton of out there, you know, MQTT, RabbitMQ, and such. We've developed our own specifically for telecommunications, WarMQ, which is used for monitoring systems, AI, traffic, you know, data acquisition. So what this gives you is an efficient set of tools or endpoints that allow to create very efficient communication across different blocks of software, instead of having a rather bulky set of code base that, regardless the application that you're going to use that network for, you're just selling it to everyone, right? So we need to move more towards feature-based rather than, you know, having one solution that fits all. And I think that is going to help us be more efficient than on the platform level, right? When we talk about cloud native and platforms, it is about containerizing all of that software and obviously managing better the workflows and the scaling up and down of the resources. But if I deploy an Open RAN network in a server and I'm using 100% of the CPU and RAM because it has so much code base that is running, there's not much I can do with the cloud tools that sit on top. So what I suggest is to start from the software creation perspective and then move towards the platforms.
Oh, that's very interesting. Thanks very much, Maria, for that. Let me come across to Komal, and you know, perhaps we could talk generally here about the idea that adoption of cloud native can help a telco towards achieving its green targets.
Yes, I think Maria raised some very good points, and building onto those, I think the very nature of going onto cloud means that we can eliminate a lot of redundant hardware to begin with. A very simple definition of getting on cloud: decommission a lot of legacy zombie hardware that's sitting in our sites. And that starts to add to the energy saving equation very quickly. I think if you look at the statistics, it's surprising to see how much quickly adds up by turning off certain hardware which has been just sitting there idle for a very long time. So that really helps. And I think one very important point by moving functions onto cloud is, and especially in the context of energy, is defining an intelligent database. I think one cannot overemphasize the importance of having an intelligent data lake towards defining more empirically based informed decisions on how we reduce our energy consumption. I always say that it's important to have an accurate or close to accurate understanding of what we are consuming to be able to reduce what we are consuming. So I think bringing everything onto cloud, this might be a little far-fetched in today's context, but once we have a good good portion of the network on cloud, it's much easier to have the counters or data synchronized into a centralized data lakes, where in reality today the data is a real challenge to be collated from disparate systems, databases, etc. And that becomes one of the biggest limiting factors to any analytics around energy. So I see that moving to cloud is a step towards having a more synced up, intelligent, centralized data lakes.
Yeah, indeed. And Komal, thanks so much for that. We do hear that from other telcos, this need for a better data pipeline management, I guess, or however you want to call that. Beth, let's come across to you next, as you'd like to comment on this one.
Definitely want to comment. And I have a number of points I want to cover. Maria brought up the need for better software that does take advantage of being energy efficient, and I would say we're probably still lacking in that area. In that software developers don't really think about energy when they're developing their code, and I think we need to create tools that will allow them to incorporate the energy as a factor when they're developing those tools. And of course, higher performance does, of course, mean translate into energy efficiency. But like the need for built-in security and built-in networking, they also need to have tools that help them optimize the energy consumption as well. So that's actually an area that I think potentially the open source community can step up into and drive that the capabilities down into the vendors that are writing this software. Second, I want to touch on what Komal was talking about the data lakes. I think we've done a fairly good job on the hardware side of things. There are definitely tools out there that can measure energy consumption, within the data center, specifically on the hardware. Although, we still definitely need to work on, the chip manufacturers have to drive a lot of that, reduced energy consumption. But the software and the tool, the observability, the ability to see what energy, how the software interacts with the hardware and how the software is energy, more energy efficient or less energy efficient. I don't think that observability is really there yet. And that's an area that I think we can, again, really work on to drive down, drive up the energy efficiency, of the software. I know we definitely have it, at least some of those types of reporting tools at the hardware level, but we don't really have much at the software level yet. And I think there's a great opportunity there. Turning off hardware, the initial transformance of, virtualized environments back that happened about 15, 20 years ago, produced huge reductions in power consumption and drove energy efficiency. But now, as we go through the second evolution, driving into container-based type software and micro microcode and serverless and other types of more, where there is potential for energy savings and more efficiency, but we're not going to see the huge leaps that we saw, 15, 20 years ago when we converted to virtualized machines.
Great. Thanks so much for those extra insights, Beth. A lot of good ideas there. And let me come across to Joan as well for your comments on this question.
Yes, I basically agree on all the inputs provided by Maria, Komal, and Beth. But maybe I will add something in addition, that it's more about the perspective of the network itself. So there have been substantial advances in so many different areas within the infrastructure. But one of the critical points is that we are not going to be able to actually deliver on our targets of reducing power consumption if we do not build a network taking advantage of all those features and benefits that we have on the platform and the infrastructure. Like, for example, if we know that we have different capabilities of the CPUs or managing the B and the C states, those can be actual very valuable inputs on how we decide from a network operator perspective where to make the placement of our network functions. Other capabilities, like, for example, being aware that we have now functionality out there that is able to put certain resources into some suspension mode. If we are not aware of it and we are able to ingest this kind of input functionalities into our higher layer orchestration levels, where we actually design and deploy the network, of course, I think that we are not going to get any real targets in the end. So again, I think it's also important to see the perspective of energy savings and consumption savings from the design and the deployment of the network itself. And for that, we need to put also more effort on trying to add more intelligence in our orchestration systems, which I think is going to be essential.
Absolutely. Thanks so much, Joan. And, it does sound like we need a bit more joined up thinking across the ecosystem to move things along at a more rapid pace. I'd like to move on to something that actually Beth mentioned a few minutes ago when she talked about containers. I wonder if a container-based architecture with Kubernetes helps reduce power consumption. Maria, do you have any insights into this one?
I think that and very much to the point that Joan was making before, at the end of the day, any infrastructure management tools, such as a container-based one like Kubernetes, or any Vim that it's out there that helps manage VMs as well, or any service level orchestration tool, will help us be more efficient, because it helps us address a lot of optimizations in the way that we manage our applications. And that obviously helps us reduce the environmental impact of the services that we are providing. All of these optimizations that at the end of the day are going to be providing a reduction in the power consumption are based on, the ability to use more efficiently the resources, the ability to scale up and down services based on the requirements that we have at the moment, the ability to package applications and make configurations to be automated, which means that we can onboard faster and reduce a lot less resources to get a service up and running. And more importantly, these tools, these infrastructure tools, allow us to look at multi-tenancy. If that means, hosting multiple services or multiple tenants at the same time. These applications, these infrastructure management tools that allow us to better manage our applications also allow us to be more, to apply more energy-aware scheduling tools, right? And often those are built-in applications that exist in some flavors of Kubernetes or in some other VIMs, very specialized VIMs as well. However, as I said, there is a lot that we can say with the infrastructure management, but if the software that we put in there, so we have to see the Kubernetes and all of that as kind of like an envelope. And inside we put our software. If our software is not efficient, then all of the optimizations that we're putting in the envelope are not fully taken advantage of. So yes, it is a lot that can be taken from a container-based architecture and a service-based architecture, such as the use of serverless. But we also need to pay attention on what we put in there in the form of what goes inside of the container, what goes inside of the VM.
Great, thanks, Maria. So, as you say, we do need to look at what goes inside there. We look at efficient software, and as was mentioned earlier, we need software and code to be written that is with energy efficiency in mind, which perhaps we're not getting to the extent we need today. Beth, let me come across to you for your thoughts on this, because I know also there's the parallel need for hardware.
There is parallel need for hardware, but and I do want to talk about that. But another issue, which is that telcos run on high availability. We need to be 100% up 100% of the time. And we also need to be prepared for peaks and valleys of the network, the Mother's Day rush or whatever it is, or Black Friday. And we have to be careful with how that's done, right? So we want to be able to turn up hardware or turn up services quickly, but then shut them down to reduce our energy footprint when they're not in use. But orchestration, as was mentioned, I think Komal mentioned it earlier. Orchestration is hugely important and VIMs are hugely important in making sure that you have the right amount of resources available at the right times, and that can be quite tricky. We certainly have patterns that we're familiar with, but we also can be hit by unexpected loads that can throw off the energy efficiency we use. And now I want to talk about hardware. At the end of the day, the software can only go so far. Hardware is, all those spinning disks. It generates heat. Most of our power efficiency is wasted on heat in the data center and cooling the equipment and the hardware vendors and the data center people really need to look at reducing the heat output, making those chips more efficient, making the hardware produce more processing for less heat. That's a very direct equation to reduce the energy footprint, and software can only go so far in helping in that area.
Yeah, absolutely, Beth. And that was something we discussed on yesterday's panel on the Green Network Summit, and also trying to get chips to operate at higher temperatures to reduce that need for as much cooling. All great ideas. Let me move on, and I'd like to ask the question if there's any more radical approaches to using software for the green network, such as has been mentioned already, serverless computing. Komal, could I come across to you on this one? Are there any new approaches that we could use that could be more energy efficient and reduce power usage?
Certainly. I think serverless computing certainly tops the list. Like Beth was alluding to, that you remove the hardware which is running 24/7 and perhaps over provision for the applications, and rather use it on a use as you go model. Definitely eliminates a lot of redundancy and saves energy. I think then there are approaches for decentralized processing or edge computing, or decentralized machine learning. I think that's still also happening a lot, where you do the processing or train the models at the source of the data, and then bring the output of these models to a more common location, rather than bringing everything in one go and using a lot of network and hence using a lot of energy. So I think those are quite useful approaches. And I think while we focus on the network side of the things, I think there's a lot of opportunity and a lot of, I think, work that's also being done on how do we sync our networks, our telco networks, with electricity grids, so that we are able to use our resources and our energy, hence our energy, while responding to grids need and becoming more sustainable in way. So, for example, how do we use our flexibility assets, for example, to use more excess generation of wind or solar on the grid and use it at different times, so that we are reducing our gray energy consumption and rather focusing on green energy consumption. And similarly, how do we flex our demand, for example, in response to time of use tariffs, or in response to simple grid congestion situations? So I think there's a lot of opportunity on looking the equation altogether, from consumer to network to energy grids, which can enhance the whole network sustainability footprint.
Well, interesting, Komal. Thanks so much for those ideas. And we're certainly seeing a lot of interest in decentralized approaches in our other summits as well. So that's very interesting. Beth, let me come across to you for your thoughts here.
I want to talk a little bit about what Verizon's been doing. Not so much on the software side, but we've invested in green energy directly, as Komal mentioned. That's if you kind of skip directly to having solar farms, solar panel farms and wind energy, and using that to power the data centers. Yes, you still have to reduce the footprint, but you're taking it out of the fossil fuel equation. So I know we've been doing a lot of work around that. We've also done, we're working on, when we build our new data centers, we build them with using the LEEDs standard, LEEDs Gold, LEEDs Platinum, as much as possible. Now, I should point out, and this is not unique to Verizon, many telcos have older data centers, I don't have to tell you, data centers are very expensive to build. So obviously, we don't build new ones at the drop of a hat. We obviously want to, get our investment out of the data centers that we've built over the years. So there is some opportunity to do retrofits, but in many cases, that's a very difficult, that's a financial decision related to investments. So, Verizon is definitely, we're proponents of doing as much as we can, as fast as we can, but there are business constraints that are outside of the telcos' hands in terms of, getting the maximum investment out of our very expensive infrastructure.
Yeah, absolutely, Beth. They certainly are expensive. Joan, let's come across to you for your thoughts.
Okay, thank you. I will add quite briefly, to be honest. I agree that there will be probably some new paradigms that will facilitate a lot on saving power consumption. There will be also new methods and technologies for the deployment of applications like using WASM and eBPF, and they are known to be efficient with higher throughput, with less CPU consumption. So in the end, it always adds to the benefit and the target of reducing power consumption. But in our experience, just only thinking about the software is not enough. And actually, the hardware part is also playing a key role. For example, we've run POCs at Docomo, where we've seen a drastic improvement and savings in power consumption just by changing the kind of CPUs that we use for delivering the 5G core. So I think it's all a composition of many different aspects that will actually help deliver these targets in the end, and not just only a single paradigm. So I hope that we can combine them all together in a very efficient manner in the future and seek for this target.
Yeah, good point. You're absolutely right. There are so many different approaches we can take, and that they will all add up, and cumulatively they'll have a good impact, especially when we talk about the scales that we deal with in our organizations. Final question before we wrap up this panel session. I'd like to come to a point that was made last summer at the DSP Leaders World Forum event. And that was about price performance per watt and best performance per watt, these targets, and whether or not cloud native can help with shifting more historic targets away from price performance on a per watt basis and more towards a perhaps more sustainable best performance per watt. And if that is indeed possible, would customers accept any possible consequences of such a move? We never resolved that question last summer, so let's have a go and see what you think today. Beth, perhaps I could start with you. This whole metric issue.
Well, at the end of the day, you can only change what you can actually observe. So observability is really at the heart of the question, and and I'm not even sure there's even a dichotomy here, because price performance and efficiency, if you're using less energy, it's going to cost you less, so you're going to get better performance, and it will also at the same time be less costly. So, I don't know if there's even a question here.
That makes our panel discussion really short. I hope there's something. There's a kernel of question in this, because, as I said, it was raised and discussed at some length last year. We never really got anywhere. But this idea of trying to price our services or value our services somewhat differently. Komal, perhaps I could come across to you and to get your opinions as to whether this matters, or if it, at the end of the day, is just performance.
I think there is definitely a compelling case here for moving from price per watt to performance per watt. But I think Beth makes a very good point that observability is key to this idea. I think we have the tools that can facilitate this shift of at least defining these metrics, delivering these metrics. But transparency and observability is a key, and that also goes into whether our customers are going to accept it. I think there's definitely it's certainly a factor of how sustainability is perceived by our customers. And I think we all have seen that there is a great market share of customers, businesses, industries who are willing to pay a premium for more sustainable, environment conscious products. But a key again to that is transparency on the initiatives, transparency on what we are delivering. And I think once that comes into play, I think with the right communication, definitely we can have a business case for this.
Oh, great points. Thanks very much, Komal. And Joan, let's come across to you for this final question.
Okay, thank you. So, well, to the first part of the question, I do really think that, of course, adopting cloud native and NFT technologies as a whole, what it provides to the operator is capabilities to be more flexible on many different kinds of services to offer to the customers. So definitely, why not? There can be new offerings that do not try to get the best performance or the highest performance as possible, but rather the best performance based on what is available to be consumed or what is actually available to be paid by the customer in terms of watts. And in that case, one of the, for example, speaking from experience in our company, to the second part of the question of whether customers will actually accept that, I'm not involved in any kind of business customer relations, but speaking as myself as a customer, I'm pretty sure that there are many different customers out there that they are also very conscious about how they purchase things and how they use them in terms of sustainability and trying to be green in the end. So definitely there is out there potentially some demand to try to broaden the set of services that we can offer to the customers. And related to also this aspect, for example, at Docomo, what we also have implemented is some kind of offerings that allow to the customers to realize what is their contribution on how they use the services that are offered by the operator on trying to achieve certain reduction in power consumption or energy. So it is actually an important aspect that from the very beginning, trying to keep the customer already engaged on this end goal, and not just only be an objective of saving by the operator, but also the customer to realize how their actions are actually helping on becoming greener in the end.
Oh yeah, great points indeed. Thanks for making those. Maria, would you like to round out our responses to this panel session on this whole issue of performance and what we offer to customers and how this links into energy efficiency?
Yeah, I think that maybe a more radical answer to this is like cloud native, not cloud native should be irrelevant for the customer. This transition to the cloud We should do it as an industry for reasons of cost saving, sustainability, and efficiency. We know that cloud native allows us to integrate AI, it allows us to reduce power and actually have self-organizing networks that help us monitor and manage those networks, right? There is a point on observability and what you can change based on what you can see. And the cloud and software-based networks would actually give us that. All of these tools, everything that we have been discussing will improve our solutions, and that inevitably will move us towards the best performance and whatever the unit of cost of that performance is, right? If it's the VAT, it is the VAT. But the point is that this is a multi-objective optimization problem, and our objective is always to get the best performance of the network. And it's no doubt that a transition to the cloud, it's inevitable to get the best performance of the network.
Great. Thanks very much, Maria. Well, we must leave it there, and I'm sure we will continue this debate during our live Q&A show, which is tomorrow. For now, though, thank you all very much for taking part in our discussion. And if you are watching this on day 2 of our Green Network Summit, please be aware there is no live Q&A show today, but do send us your questions and we'll try and answer them in our live Q&A show tomorrow. The full schedule of programs and speakers can be found on the TelecomTV website, which is where you will also find the Q&A form and also our poll question. Do take part in that. For now, though, thank you for watching and goodbye.